the peak amplitude of the upper and lower side frequencies. Okay, so which means that you have to find the amplitude for the upper sideband and also the lower sideband. So we know that the singleton modulating frequency with the amplitude produce plus minus 14 repeat change in the amplitude of the envelope. Okay, so which means that the amplitude of the lower sideband and also the upper sideband would be given by this. So it's 14 divided by 2. Okay, so since we know that the spectrum, we have the FC, and this is the side frequencies, right? The lower and also the upper side frequencies. So usually we'll have the amplitude here. For the side frequency, it will be the same. Okay. So here we can see that the amplitude at both sides, the USF, will be the same, which is 7 repeat. Okay, so this statement will be important lah, where you want to determine the value, okay, for the upper and lower side frequencies. So which value you will have to take. All right. Next is on the modulation index. So we know that modulation index is given by this relationship. So we have 14 0.4375. Okay, so the percentage of the modulation simply times the 100%. So you will have around 43.75. Okay. So next question, the maximum and minimum positive amplitude of an AM envelope. So which means that you have to find your Vmax and Vmin. Okay, so the maximum and the minimum positive amplitude of an AM envelope. So how to get here? You will have to sum the value of your carrier amplitude and also your modulating signal amplitude just now. Okay, so Vmin will be the difference. EC minus okay so far. So this question also asks you to illustrate and label the envelope, okay, of this AM modulated wave. So you have to draw sketch the AM modulated wave with the label of which one is your Vmax, which part would be your EM, which part would be your Vmin. Okay. So this is the positive Vmax, positive Vmin. This part is the negative part of your Vmin and also Vmax. Okay, so this is the reference of your EC, the carrier, and this is your modulating signal. So inside would be the carrier plus the upper and the lower side frequencies. This is the envelope. Okay, the one that we talked about, the envelope. It's not the frequency spectrum. If we want to sketch the frequency spectrum, then you need to sketch like this. This is your FC, FC minus FM plus. So put the amplitude here. What would be the amplitude of this signal? Apa tadi? 30, 32. This is 7. Okay, so this is the frequency. This would be the frequency spectrum. And the last question asks you explain what will happen if the peak amplitude of the audio signal is higher than the peak amplitude of the carrier signal. Okay, so peak amplitude of the audio signal is actually your VM. Peak amplitude of me is your carrier VC. Okay, so if you have VM more than VC, what will be the condition? We will have the modulation index more than 1. Okay, so therefore the over-modulation will occur. So the signal will be distorted and the original signal cannot be retrieved at the receiver. Okay, if you retrieve but still it will be not in the original condition. Okay, done for question 1. Any question? Any doubt that you want to ask?
No, Major.
Okay. So can we go to question 2?
Can.
This part would be on more on the power calculation lah. Okay, the one that has been that I give the lecture by today, okay, this morning. So given the total power of an amplitude modulated wave, which is 2500 watt, evaluate the power content of the carrier and each of the sideband power if AM signal is 60% modulated. Okay, so it's give the percentage of modulation with 60%. So which means that your modulation index 0.6. Okay, so to calculate the power content at the carrier and also the power sideband, okay, you need to know that we have PT is given by PC plus PUSB and PLSB. Okay, so in summarize, we know that the value is so this is the formula to calculate the total power. Okay, So the total power given is 2,500. So we know the PT value and we know the value for this modulation index. So you can find the value for PC. Zero 0.6 squared. So that would be the value for your PC. 2118.64 watt. Okay. So how about the power for each sideband? So P USB and PLSB is given by 1/4 of the power. Okay, so this is the condition for the double sideband full carrier. Okay, so from here you can calculate 0.6. Correct. Right or not? Can you get the same answer? 190.68 watt. So if you cannot find the value of this PC, then it will be hard for you to find this value, the sideband power. Okay, so make sure that you calculated this value correctly, because this question is related to each other. Okay, dapat ke? Ada soalan tak? So what is important here, you have to know what is total power. So total power is given by this formula. I have done some derivation on this, okay, how to come up with this formula. So the simplified version from this formula, okay, the expression. So please go through the video if you didn't go through it yet. Okay.
Okay, madam.
Okay. So next question is basically asking you to prove that the total current at the transmitting end can be calculated using this formula as well. Okay, so in real world, it is difficult to determine the AM power by measuring the output voltage and calculating the power with this expression. So however, it is easy to measure the current in the load using this RF emitter. Okay, so provided that the antenna impedance is known lah. Okay, so the output power is easily calculated. So proof that the total current at the transmitting end can be calculated as the I total is equals to IC, the current at the carrier, okay, produced by the carrier, square root of 1 plus m squared over 2. It is more like your total power expression previous question. Okay, only that here in this part, it will be in term of the total current. So how to prove that? Basically, we will start with that PT. From the previous question. Okay, so same, right? So now we will find what would be the value to calculate the power based on the current. So this one IT squared. So since this the impedance is the same, so we can override that value. So we left with only the current expression. Okay. So you have to start by this total power. Okay, and then take the expression of each power with the current. Okay, and then simplify that. So at the end, you will get the same total current at the transmitting end as in the question. All right. So based on that, you have to calculate the modulation index, the total load power PT if the given antenna has an impedance of 75 ohm and experience an antenna current change from 8 unmodulated to 8.4. So which means that your IT is 8.4. So this is the value that has been extracted from this statement. Unmodulated, so the carrier, and then the total. This is the total 8.4. Okay. And then what are other expression that you need to find? Is actually the modulation index. Modulation index and total power PT. Okay, so to find PT, you have to determine your IT squared R. Okay, the modulation index basically based on this formula IT. Okay, we know that our IT is 8.4. This one is 8. So ini will be more on the mathematical calculation lah. Okay. So boleh solve ke daripada sini? Can you try finding the value for your modulation index? Boleh sambung. Try to calculate and then give me the value of the modulation index. Dah habis calculate. Dapat apa value of modulation index? M.
Adam, is it 1.098?
Hmm?
1.098.
1.098. Your M.
M.
Should be less than 1. M to M squared. Okay, so make sure that you square root that value, what you get, getting the M. 1.05 square root squared is about okay, so the next step, you can minus this 1 here. So what left is your M squared over 2. Okay, so when you minus this 1, apa yang tinggal kat situ?
0.1025
times 2.
times 2.
That these two going up, right? Okay, so now your M is square root of this value.
Zero 0.45.
That's your value
Yes,
of
madam.
the modulation index. Okay, so now the total load power. So we know that our total power is already been given 8.4. R is your 75. So it's about 5.2. Okay. So it's a little bit tricky here if you don't understand this kind of statement. Okay, so what to do with this value 8.4 and 8 here? Okay, so basically this kind of equation need you to have a better knowledge lah. Okay, what will happen to the current change. given unmodulated or modulated. Alright, so you have to be careful when reading the question. This one just give what are the advantages and disadvantages of your AMSSB. Okay, so originally we have this double sideband. Okay, and then we have also the single sideband. Okay, just to improve some of the disadvantages. Okay, so for single sideband, usually will offer more efficient power consumption. Okay, much less total power transmitted is necessary to produce the same quality signal achieved in the AM DSB. Okay, so what's the problem in this TSB? It has a large power at the carrier itself. Okay, so usually at this FC, so that would be the total power loaded here. So that's why they come out with this SSB, where only either you are using the surprise carrier or the reduced carrier, only one sideband that will be transmitted, but with the same power consumption. Okay, so the bandwidth utilized is 50% less compared to your AM DSB. Okay, so here you will have your bandwidth is 2 F max, but for the SSB is only your FM sajalah, either this side or that side, whichever side is the same. Okay, so the noise is lower because of the lower bandwidth. Okay, so we know that the noise can be calculated using this KTB. The spectrum space is conserved because of the lower bandwidth, so more signal can be transmitted. Alright, that would be the advantage. Next question. An antenna transmit a 10K power, okay, at 95% modulation using conventional AM. So calculate the amount of power saving if single sideband transmission is used for the same intangibility. Okay, so given your PT 10 kilowatt, the modulation index given in the percentage of modulation, so it's about 0.95. So for the conventional AM, the total power is basically given by this upper second plus the lower side band frequencies. Okay, so just plug in the value of PT and also the modulation index, you will get in terms of PC lah. Okay, so your PC 1 plus 0.5 squared. So calculate, we're gonna put around okay, so PT. We already have the power given 10K. So from there, your PC is about Okay. So now calculate for the second part, which is your SSB. So we assume that this is a full carrier SSB lah. So we have PC plus either PUSB or PLSB. One sajalah dia punya site. Okay, so PC we already have here. M squared 0.95. So for single sideband, for each sideband is basically M squared over 4. Okay, so this one is over 4. Times the PC itself. So how we get this? It's basically from this formula. Okay, so PUSB so the power at each sideband is actually 1/4 of the total power at the PC. Okay, so it's the same lah for PUSB and also PLSB. So that's why when we all do all this calculation, then simplified, then you will get this. Okay, so from here you calculate and then what you get for the total power. Okay, 8446 or 8.4 kilowatt. Okay, so the power saving calculating from PT. Get around 1.5. So that's the power saving lah that you get. For the conventional is 10K just now. Okay, so the percentage of this power saving. 15.54. Okay. So using the conventional AM, you will have the power around 10K. So when we use the single sideband transmission, the power, okay, so the total power used for the transmission is only up to this, okay, which is less than 10K lah. Okay, so that's why we have calculated this difference to find the power saving. It's about 15% difference. Okay. So last boleh buat SSB SC transmission contain 10 kilowatt. This transmission is to be replaced by a standard amplitude modulated signal with the same power content. Determine the power content of the carrier and each of the sideband when the percent modulation is 75%. So it's almost the same as the previous equation, but here you need to do the other way around. Can we try? So here the total power of your SSB SC is equals to the PT equals to 10K. So the total power for the conventional AM okay, so which is 10K. So you just use this formula to find the value of your carrier and the sideband. Okay, so PUSB is equals to PLSB. We know that it is about of your PC. So it's divide by 4. Okay, so ataupun what you can do to find this sideband is based on your PT minus PC and then divide by 2. We will get the same answer. 10K tolak alright. So finish all the 2 question. Any other question that you want to ask?
For now, no, madam. For now, all good.
Okay boleh jawab soalan malam ni?
Boleh, madam.
Stop the record.